All right, so in this lesson, we're going to talk about inequality word problems. A person less than 16 years of age can work up to 40 hours per week according to child labor laws. A 15-year-old student plans on working 2 summer jobs, one at a fast food restaurant and one at a retail store. Okay, so first they ask us to write and graph an inequality that represents the possible number of hours the student can work. And then it says let X represent the hours worked at the fast food restaurant and Y the hours worked at the retail store. So you can see the graph is kind of set up for us. And you'll also notice that if I were to make a coordinate plane, they have only graphed this quadrant 1. And the reason for that is because I can't have negatives. I can't work negative fast food hours or negative retail hours. So that will sometimes be the case with word problems. And something to consider for sure. Okay, now we're going to write our inequality. And a lot of times when you see word problems, as we get into higher level math, there'll be numbers in there that might be extraneous. In other words, numbers you won't use necessarily. And that is the case. There's a couple here that we're really not going to be using in our inequality. So always use your close reading strategies to be careful of those things. So a person less than 16 years of age can work up to 40 hours per week. So really, this is mostly what we want to focus on. I know that X is fast food hours, and I know that Y is retail hours. And if I put those together, I can go up to 40, but not over. So X plus Y, put them together, that has to be less than, it can be equal, so less than or equal to 40. So take some time, make sure you get the right inequality. And these are, you'll note, inequalities, not equations. So don't put an equal sign there. That is not an inequality. Okay, so now what, the second one, we need to graph this. So let's do that. So the easiest thing to do here is to use the cover-up method. In other words, cover this up, plot your x-intercept, then cover this up and plot your y-intercept, right? So that means if you do that, cover up the y, you get 40 for your x-intercept. And we would also have 40 for our y-intercept. Okay, and now I want to draw my line in between those. Okay, and then I want to shade one way or the other. And because this is less than or equal to, if I plug in 0, 0, I would be shading, down this way. So let's do that shading. Say, Mr. Chisholm, you're all over the place. You're way outside the lines. Yeah, I'm going to take care of that. I found it's a little easier to do it this way. Okay, so there's my shaded or solution region. That means anything in this green shaded region is a solution, okay? So any point that represents that. All right, so now it says, what does the point 1013 represent? Well, X we said was fast food hours. So this student worked, if 1013 would be 10 fast food hours, and 13 retail store hours. All right. Now, is the point 1013 a solution? Why or why not? All right, well, 1013, if we look here, is about right here. It's not even close to the boundary. It's definitely in the shaded region. So yeah, that's a solution It's in the shaded region. So we can just say, is the point 10, 13? Yes. It's in the shaded region. Okay. Next, it says, what does the point 25, 16 represent in this problem? So similar to part B, 25 is the fast food hours. That's X. And 16 would be retail. Okay, so 25 fast food hours worked and 16 retail store hours worked. Is this point a solution? Now, 25, 16, if we look, 25, 16 is probably somewhere like, I don't know, right there. Right about there. It's maybe on the line. So this one is a little trickier. You can't necessarily use the graph because that could be slightly off. So then really what you want to do is go back to this inequality. Okay, now if I plug in X, 25 plus Y is 16, is this less than or equal to 40? Okay, well this is 41. Okay, that is a false statement. 41 is not less than or equal to 40. So that point is just a little bit outside the shaded region there. It's over 40. We could be 40, but we can't be over 40. So this one is definitely over 40. So is this a solution? No. So inequality is false. We can see that right there. Okay. All right, so that's our first word problem. Hopefully that makes some sense. All right. Now, next problem says, you offer to mow your neighbor's lawn for $20 or to wash their cars for $10. Your goal is to earn at least $1,500 this summer. Write and graph an inequality that represents the possible number of lawns you would have to mow, X, and the cars you would have to wash, Y, in order to reach your goal. All right. So let's go back up here. We know lawns. I'm going to use a different color. Lawns, $20 each time. Car washes, $10 each time. And you want to earn at least $1,500. Okay, so X is lawns, so 20X. I will also make $10 for each car wash. Okay, at least is $1,500 or more, right? It's okay if he makes more than that, or she makes more than that, or they make more than that. So it's greater than or equal to. Can be 1,500, could be more. All right, so now I've got this. Now I want to graph this over here. Again, you want to use this cover-up method because it's in standard form. So I'm really going to say my x-intercept would be, cover that up, I would have to take 1,500 divided by 20, which would give me 75. So now 75 on the x-axis is not real easy to graph, right? This is 60. This would be 70. So halfway in between there would be 75. So it's somewhere in that region, but it's a little tricky to get there. So I'm going to do the best I can here. Okay, we'll say it's about right there. All right, now if I go back, I cover up my x now, then I would have 10y equals 1,500. Divide by 10 on both sides, that would give me 150. Okay, well that's a little easier to plot. All right, so now I'm going to draw my line. Okay, I'm trying to get that as accurate as I can. All right, so now I want to figure out which way am I shading. All right, now it says greater than or equal to 1500. So now if I put a 0 and a 0 in there, I would get 0 is greater than or equal to 1500. That would be a false statement. So I want to shade away from 0. So I'm going to do that. Okay, so it's everything on this side. And once again, I'm going to clean this up a little bit. All right, a little better. So now I've got my shaded region. All right, what does the point 50, 65 represent in this problem? So 50 would be the number of lawns mowed, that's my X, and 65 would be the number of cars washed. Okay, so there we go, that's part B. Is the point 50, 65 a solution? Why or why not? So let's look at our graph. 50, so 50 is, oops, 50, 65, probably a solution. It's somewhere in that neighborhood, right about here. It looks like it might work, but this one's a little too close to tell. So what you want to do when it's a little too close is you want to try and plug in. So we're going to go 20 times 50 plus 10 times 65. And we're going to see if that works, okay, if it's a true statement. So 20 times 50 is 1,000. 10 times 65 is 650. Okay, so we would get 1650 is greater than or equal to 1500. Is this a true statement? Yes. So that means the point 50, 65 is in the solution region, and why or why not? That's the reason why. Okay? So if it's kind of close, use the inequality. All right. Find a point that lands on the boundary line. Explain the specific meaning of this point. Okay, so what they want is any point on our blue boundary line right here. Not in the shaded region, but on the boundary line. Okay, so you can pick any of the ones kind of in the middle there. That one will be a little trickier maybe to figure out, because you might have a hard time saying, well, is that really on the line or not? And you would have to plug into the inequality to be sure. Probably the easiest 2 points would be your 2 intercepts. So I kind of like that point right there. On the boundary line, 0, 150. That's 1 point. Of course, there are infinite other points here you could have. I guess not infinite, but a lot of other points you could have. Explain the specific. Is this a solution? Yes, because this boundary line is solid. If it were dashed, then that would not be a solution. So explain the specific meaning of this point. So 0, this would be 0 lawns mowed. 150 cars washed. Okay, that's it. I hope this makes some sense and you understand this as we went through it. All right, good luck on the assignment. See you later.